morning students. So we will start with queues in data structure today. So I just gave a brief introduction about queue to you. What is a queue? Queue behaves in a certain manner called FIFO manner. First in, first out. Okay? First in, first out. It is a, we can describe it as a linear data structure in which insertion can happen from one end called rear end and deletion can occur at one end called front end. From the front we can delete data and from rear we can insert data. Okay, this is the nature of queue. So this is what pretty much happens in queue. The two main important functions in queue are two operations. One is NQ, another one is DQ. So what is NQ, what is DQ? NQ is the process of inserting element from rear end. Okay, so what is NQ? NQ means inserting element from the rear end into the queue is called NQ. Similarly, what is DQ operation? DQ operation means deleting elements from the front end. Okay, so deleting elements from the front end is called DQ operation. Okay, so queue is a data structure, linear data structure in which we can insert element from the rear end, that is from the back end, and we can delete elements from the front end. Okay, this is the property of queue. That's why it is called to be working in FIFO order. FIFO order means whichever that is in first will be out first. First in, first out. Okay, so you can compare queue with the railway ticketing system or any service-based system in which the person who arrives first is served first. Okay, the person which arrives first is served first. Okay, so that's why it is said to be working in FIFO manner. Okay, so this is what pretty much about queues. So we will see how to formally define a queue. Okay, how to formally define a queue in C language. Struct queue. Okay, struct queue. What is there in the queue? First, there is an integer pointer front and there is another integer pointer called rear and there is an integer array, suppose ARR, which is of size n. Okay, and we will define n something. We will define n as something, n 5 or 8 or 10, whatever. Let's take 10. Okay, keep it simple as 5. Okay, so this is how a queue looks like. We have an array of 0, 1, 2, 3. Since the size is 5, it will continue till 4. Now, front will point to the first element, rear always point to the rear element. But initially, before initializing it, by default, front and rear should be -1, -1 because there is no element in the queue. Since rear always points to the last element, right? And front always points to the first element. Okay? So rear and front index depends on what is inside the queue. Okay? So if there is one element inside the queue, suppose there is one element inside the queue, 10. So front will be pointing to the first element. And what is the last element? Last element is also 10, right? So rear will be pointing to index C. So both front and rear will be pointed to index 0. Suppose I enter another element called 12. Now rear will point to where? Index 1. Because we are inserting from the rear. Next, again you want to insert. You want to NQ. Insert means same as NQ. NQ operation. NQ means inserting element from the rear. Now again you want to insert 15 suppose. Then rear will be updated to this, isn't it? You got the idea. And what is DQ? DQ means deleting element from the front. I want to delete that. Then front will be updated to where? The first element. What is the first element? Then 12, isn't it? So front will be updated to index 1. Okay? I hope you got the idea how front and rear change their position. But when there is no element, suppose there is no element, the size is 5, but there is no element, no NQ operation has been done so far, that means front and rear will point to -1. The index is -1. So by default, these are -1. By default, these are initialized to -1. So let's initialize Q, and we will define the NQ operation and DQ operation as well, and we will then analyze what is the problem with normal Q and why do we choose to use circular Q. Okay, so we'll understand further what is circular Q, but first let us define initialize the Q and see the NQ and DQ operations. Okay, so I'm dropping this. So our size is 5. I hope you noted all that. Now let us, define the Q. So initialize, I'm writing a function, initialize Q star Q. Okay. Now in this is a pointer to an instance of Q. This Q means the structure Q. This Q means a variable of that Q. When defining the structure is different thing, initializing it with a variable is a different thing. Okay? When I say I am defining a human, okay, so I will define struct human. What does human have? Legs, nose, eyes. I am defining all this. But actually creating a human is a different thing. When I create a human as human Ram, when I give a variable named Ram, then we actually create a human. This is what we do in computer science as well. Just defining the struct Q is not enough. By that means we will know that Q has, rear, front and an element. That we got. But actually giving a space to it is done by referring it with a variable. So this is the variable Q. Now, with this Q, what we have to do? We have to initialize it. So front is initialized as -1. Okay. Then rear is initialized as -1. Okay. Then initialization part is done. Actually a Q is created. Okay. Actually a Q is created. Now we have to check. See what is NQ? NQ means adding an element from the rear end. Okay, and DQ means deleting an element from the front end. Okay, now can we perform NQ if the Q is already full? If the Q is already full, we define the size 5. If 5 elements are already present in the Q, can you do any NQ further? No. So this we have to keep in mind. Similarly, while DQing, while performing DQ, if you want to delete an element from the Q, you have to make sure that it is not empty already. If it is already empty, we cannot perform deletion on an empty Q. Okay, so that's why we have to first define whether Q is empty and whether Q is full. After that, we can perform the function called adding an element, that is NQ, and deleting an element called DQ. Okay, so let's see that. How to check whether Q is empty or not. Okay, so Q full, I am defining it as Q full, Q, which Q? This Q. Okay, so when is Q full? Think. Suppose 10, 12, 15, 18, 17 is there. What is real? Real is 4, right? It is the last index. Last index plus 1 equal to size. When this is the condition. Okay, so what is 4? Real. So if real plus 1 equal to size, or we can say, what is the size we define? N. Okay. If real plus 1 is equal to n, we say Q is full. So let's write that. Excuse me. So if R plus 1 is equal to n, we say printf Q overflow. That means it is already full. We cannot, that means Q is full. Okay, Q is full. Okay, so this is how it is. Else, what? Q is full. Return 1. The return type is integer. Return 1. That is true. That is Q is actually full. Else, return 0. 0 means false. Okay. That means Q is not full. Okay. If this condition is true, that means Q is full and it will return 1. Otherwise, it will return 0. Okay. Now, this was the logic for Q full. Similarly, what is the logic for Q empty? Think. When is Q empty? Q is empty when front and rear is equal to -1. Both are equal to -1. This is the condition when Q is empty. When no element is present. Okay, so let's write that. Let's write that. Int Q empty. What is the function? This is the function. So condition is if front equal to rear equal to -1 equal to front equal to -1 and rear is equal to -1. And when both are -1, we say printf Q empty return 1. That means true. The Q empty is true. Else return 0. That means no, it is not empty. This was the function. So you can note it down. Okay. Both the functions you can note it down. This is the logic for finding whether Q is full or not. This is the logic for finding whether Q is empty or not. Okay. After that, we will perform the most important operations of Q, that is NQ, which means inserting an element into the queue from the rear end, and DQ operation, that means deleting an element from the front end of the queue. Okay, so we will see that shortly. Just note it down and write it down. We'll pause the video and note it down. Now let's see NQ. Okay. NQ star Q. We have to NQ some element, right? So we can give it in the function int x. Suppose we want to insert x. So these are the arguments. This is argument 1, this is argument 2. Now for NQing, what we have to check? We have to check whether the Q is already So for NQ, we have to check whether Q is already full or not. If it is already full, we cannot further NQ into it. We insert element into it. So first we have to check if Q full. If Q full is true, this is a function, no? We will call it. If Q full is true, printf what? Can't enqueue. We cannot enqueue. We cannot enqueue. Else what we can do? What we have to do? We have to check. Suppose this is the queue. We have 5 slots. See, I'm always getting trouble because of this markers. 0, 1, 2, 3, 4. Now suppose queue is full, then we cannot perform in queue. We will just say return. Will return. It will not use anything if queue is full. Otherwise, what will happen? If it is empty, then what will happen? We will insert x into it and we will update f and r as index 0. Okay? So that we have to write. Else if front equal to -1 and rear equal to -1, if Q was empty, then what we have to do? We have to increment f plus plus r plus plus, okay, and Q rear, because insertion has to be from rear end, Q rear equal to x. So we are putting x into it. First we will increment. I hope you are understanding what we are doing. Q is empty. What we are doing? If this is the condition, if Q is empty, what will happen? F will be incremented since f and rear were. Since f equal to -1, rear equal to -1, they will be incremented f plus plus rear plus plus. So f will be pointing to here, rear will be pointing to here, and q are equal to x. What is r? 0. So x will be placed here. Okay, got it. So we understood this. This is what will happen if q is empty. If q is not empty, suppose this is the case, then already some elements were present, like 12, 15, something is there, and we want to insert x, except some value, okay, whatever value. Now what will happen? Now x will be inserted, then in that case what will happen? We will just increment rear. In that case rear is initially here, front is initially here. If this is the scenario, what will happen? We will simply put the x element here, isn't it? So what we will do, we will increment rear and we will put the value x in q rear. Okay? So this is what we will do. That is the third possibility. That is else condition. Else, this is the last one. Else if this is the, we have to give a bracket here. Okay? Else what will happen? You simply increment rear. R plus plus QR is equal to x. This is the case. And after which we will return 1. Okay. So this is the entire function. Okay. So we can have basically 3 conditions. Whether the queue will be full, then in that case we cannot perform in queue. Otherwise the queue would be empty. Then in that case what we will do? We will put the first element, okay, and we will increment front and rear both. Okay, in that case front will also be updated, rear will also be updated. If queue is empty and we are putting a first element, then both front and rear will be updated. Otherwise, if there are already some element, then we just need to increment rear and put the element to be inserted into that index. Okay. So this was about NQ. I hope you understood. Now we will perform DQ. How to delete element from the front end of the queue, we will see. You can note it because it is very, very important. Now let's perform DQ. Now what happens in DQ? We have to delete element from the front end. Now can we perform deletion if the queue is already empty? No, right? So we have to check that. So what we will check, if queue empty is true, then what will happen? If queue empty is true, if it is actually empty, then what will happen? Printf cannot perform DQ. Cannot perform DQ, it will print and it will simply return without doing anything. Okay, return. Else if we can say, if this is the case that there is only one element left. Okay, there is only one element left. 0, 1, 2, 3, 4. So suppose this is 10, this is the only element left and we want to delete it. Okay, we want to delete it. Then what will happen? Whatever front and rear were, they will be, front and rear were pointing to here, right? Front was here, rear were, they will be, after deletion, front will be -1, rear will be -1. That is, empty condition will be true. So in that case, what we will write, if front equal to rear, okay, if front is equal to rear, when will front and rear will be equal? When there is only one element, or if it is empty, then only front and rear will be equal. Okay, so if it is not empty, if this case is not true and still front and rear are equal, that means it has only one element. So in that case, what will happen? In that case, what will happen? We will simply, we have to define and keep a temporary variable. Why temp is defined? Because we need to get the value out and put it somewhere, right? So we will simply delete it. We will get what? Q rear, sorry, Q front. From Q front, QF, we will get it to temp. It is stored in temp. So temp will be stored in temp. Then we will decrement. We will decrement front and rear, because now there is no element here. So if this is the scenario that only one element is present, so when we delete it, we extract it into the temporary variable and we decrement front to -1 and rear to -1. Okay, so this happens when there is only one element. Now else, the last condition is when there are multiple elements and you are deleting, then what will happen? Simply we will delete from the front end and we will increment front. Okay, and we will increment front. Okay, so if this is the case that there is 10, some 15, 18, these are present. Okay, 0, 1, 2, 3, 4. Now suppose you want to delete this element. Always this will be front, this will be rear. Now we will, to delete this, what we will do? We will simply delete the element and store it in temp and we will increment front. Front will be pointed to where next? 15. Now the first element will be 15 because 10 is deleted. This is what DQ is. So we will just write the logic of this. So what is the else condition? Else what will happen? Else 10 means QF. Okay, then we will increment front F plus plus. Okay, then what we will do? We will return temp. how to perform DQ. So in DQ there are three cases. If already Q is empty, we cannot perform DQ. And if there is only one element in the queue, then we have to get the get the element out through temp, and we have to decrement the front and rear. Otherwise, if there are multiple, in normal case, if there is multiple element present already, then we have to just take the element out from the front end, and we have to increment the front, and we have to get the element that we just DQ. Okay, so it will return 10. Okay, so DQ always gives an element out of the queue, and Q always, inserts an element into the queue. So this was the entire logic of NQ and DQ. So if you have any doubt, you post it, or you can ask me in the Zoom class. Okay. So I think we discussed enough in this class. In the next class, we will understand that what is the problem that lies with this normal queue, and why do we choose to operate through circular queue. There is a big problem with this. We will discuss this in the next class, and we will understand that how circular queue is advantageous, and how it overcomes that problem, and what is circular queue, and how to define, and how to NQ and DQ, how to perform NQ and DQ in circular queue. We will understand with the entire code in the next class.